Hey guys, today what we're going to be doing is looking at using Pythagorean Theorem to find an unknown side. So what I want you to do is open up 6.2b and we are going to work on these notes together. So it should be the days before spring break. It's funny I'm making this and Mia's not born yet, but when you're watching this, Mia will be born. So crazy. So what I want you guys to do is I want you to take out 6.2b, and what we're going to do is it should be shorter, and so you guys can start your homework. I really want you to finish your homework before end of class so you guys don't have anything to do during spring break. So what we're going to do, it says provide an example of the Pythagorean theorem and define the Pythagorean theorem. So what I want us to remember is we should have learned that the Pythagorean theorem is used to find a missing side of a right triangle. So if I were to bring this up, I'd have a base, how to have another leg, and a right triangle is a triangle that forms a 90 degree. Now there's three parts to a right triangle. You have the legs. The legs are interchangeable. The thing that is not interchangeable is the hypotenuse. The hypotenuse is always across from the 90 degree angle. So it does not matter what your triangle looks like. What I mean by that, if it is rotated in any certain direction, it does not matter. The hypotenuse will always be this highlighted side. That will be the hypotenuse. It's the longest side. It's always across from 90 degrees. So one more time, it doesn't matter. That highlighted side will always be the hypotenuse. Okay? I like drawing them like this. This is how they look neatest to me. Now the thing that can change is your legs. They're both just labeled as legs. And so what I mean, it doesn't matter. This could be your A value, this could be your B value, or this could be your A value, and this could be your B value. It doesn't matter. But what is always for certain is this value is always C. Now, as a quick reminder, the formula for Pythagorean theorem is A squared plus B squared equals C squared. This formula is going to be used to find missing sides of a right triangle. So it says directions. Use the find the length of the hypotenuse for each right triangle shown below using the Pythagorean theorem. So I want you guys to realize that here is my right angle, and across from that is my hypotenuse. This is always the longest side. So I have A squared plus B squared is equal to C squared. And it doesn't matter if this is A or B. So you could have this being A and this being B, or vice versa, this being B and this being A. Doesn't matter. I'm just going to say 9 is my A and B is my 12. And I'm going to go ahead and solve this now. So all we're going to do is plug these in the formula and find my C value. So 9 squared is 81 plus 12 squared is 144 equals C squared. So then I'm going to add these two together. You guys can take out your cell phones and use your calculators. I'm going to go ahead and bring up mine right now. So I'm going to bring up my math tools, and then I'm going to have 81 plus 144 equals 225 equals C squared. Now when I take the square root of both sides, I'm looking for two numbers that are exactly the same that multiplies to 225. As a quick reminder, anytime you take the square root, that gets rid of the squared symbol, so I'm left with just C. And the square root of 225 is just 15. Okay? So that means the missing side length of this triangle is 15. So let's go ahead and look at the next one. Like I said, guys, this triangle has been rotated. Here's the 90 degree angle, so across from it is my hypotenuse. So therefore, that value, this 12, must be C. So that means I'll make this 8A. Doesn't matter if you make it A or make it B. And that makes this X my B value. So now when I plug these in, it's going to look like 8 to the second power plus B to the second power is equal to 12 to the second power. This will be 64 plus B squared is equal to 144. So if I do 144 minus 64, I'm going to get 80. Now if you notice, 80 is not a perfect squared. So what I'm going to have to do is make a factor tree. You make a factor tree by taking the square root of both sides, and you're going to be left with just B. Now let's see if we make a factor tree. If I look at the square root of 80, you look at any two numbers that multiply to 80. This could be 2 and 40, 8 and 10, 40 and, excuse me, I said 40 and 2, 4 and 20. It doesn't matter. Students tend to like dividing by 2, so I'm going to just start dividing things by 2. So 2 and 40, 2 and 20, 2 and 10, 2 and 5. Now I'm looking for the square root, so I'm looking for pairs of 2. So I have a pair of 2 here, and I have a pair of 2's here. Therefore, I just took out one set of 2's, which I'm going to highlight right here, and I'm going to take out another set of 2's that I'm going to write right here. And whatever I have not taken out, I'm going to leave inside the radical, inside the square root. So I didn't touch this 5. So that means b equals 2 times 2, which is 4, radical 5. Therefore, the length of this x is 4 radical 5. All right, so now let's go ahead and look at this one. Once again, I'm given one leg and the hypotenuse. Quick reminder, the hypotenuse is always across from the 90-degree angle. That is always my c value, and it is always the longest side. So now I'm going to have 24 to the second power plus b to the second power equals 225 to the 25 to the second power. So 24 to the second power is 576 plus b squared equals, I believe, 650. Let me see, 25 times 25 equals 625. 625. So I need to get that b squared by itself, so I'm going to minus both sides by 576. And this is going to give me b squared equals 49. Now this one's easy. There are no crazy square roots or anything. I just know when I take the square root of both sides, I get rid of the square root, and I'm left with just b, and the square root of 49 is just 7. So that means this missing value right here is 7. Okay. All right, so now what we're going to do is we're going to do the same thing with decimals. Don't be tricked with decimals or scared, which is the same formula. I'm solving for my c value. It's my hypotenuse. It's the longest side. So I'm just going to plug this into a squared plus b squared equals c squared. So I'm going to have 0.8 plus 0.6. Both of these are going to be taken to the second power, and that's going to equal c squared. That's going to give me 0.64 plus 0.36 is equal to c squared. When I add both of these up, I'm going to get 1 equals c squared. And when I take the square root of both sides, I'm just going to get c is equal to 1. So that is my hypotenuse. Now guys, quick reminder, your hypotenuse is always your longest side. So you can do a quick, it won't be 100% accurate, but you can just say, hey, look, 1 is bigger than both my legs, therefore it makes sense. If you got an answer like 0.3, 0.3 is not larger than both of these, so then you knew you'd make a mistake. All right, so one more time, this triangle is kind of bent or tilted, so we might be kind of confusing. What are my values? So just a quick reminder, here's the hypotenuse. Across from the hypotenuse, right angle, across from my right angle is the hypotenuse. That's my c value, that's the longest side. So I'm going to have a equation that looks like 0.12 to the second power plus b to the second power equals 0.2 to the second power. 12 hundredths to the second power is, 0.0144 plus b squared is equal to 0.04. So then I'm going to minus 0.04 on both sides. Excuse me, 0.04. And that's going to give me an answer of b squared equals 0.0256. Now, there are two ways to solve this. You could take the square root of both sides, but let's say you don't have a calculator. So maybe I won't give you a calculator for the test. So what you're going to do is you're going to put this in a fraction. You're going to get b squared equals tens, hundredths, thousandths, 10 thousandths. So you're going to have 256 all over 10,000. And let me make sure I can take the square root of 10,000. So if you were to take the square root, let me take a step back. So you're still going to take a square root of both of them. Whenever you take the square root of a fraction, you're essentially taking the square root of the numerator and the denominator. So when I take the square root of 256, that is going to be 16, and the square root of 10,000 is 100. There are no more square roots. You already did them, so you don't need to continue having them. And all you do now is simplify. So this would be 8 over 50, which would then again reduce to 4 over 25. Therefore, your b value is equal to 4 over 25. Okay? All right, so let's go ahead now and look at the next one. Same idea with fractions, okay? So one more time, here is my right angle. That must make this the hypotenuse. Therefore, my formula will look like 1/2 to the second power plus b, which is my missing value, to the second power, equals 3 over 4 to the second power. This would give me 1 over 4th, because 1/2 times 1/2 is 1/4, plus b squared is going to equal, I'm going to distribute this to the numerator and the denominator to get 9 over 16. I'm now going to minus 1/4 onto both sides. And 1/4 is equivalent to 4 over 16. I'm doing that so I can get a common denominator. So that means I'm going to have b squared is equal to 5 over 16. Now same idea, I'm going to take the square root of both sides. And as a quick reminder, when you take the square root of a fraction, you're going to take the square root of the numerator and the square root of a denominator. So radical 5, there is no square root, so I just leave it as radical 5. And my denominator is the square root of 16. The square root of 16 is 4. There's nothing more you can do there. So your b value is equal to radical 5 over 4. And that is your final answer for b. All right, so now this one looks a tad trickier because there's lots of square roots. But the process stays the same. So I'm going to have 2 radical 5, and I'm going to have a square root here, times a to the second power, plus a to the second power, equals 4 radical 10, and that will be taken to the second power. So I'm going to distribute this 2 to the second power to the 2 and the radical 5. This will be 2 to the second power times 5 to the second power, plus a squared is equal 4 to the second power times 10 to the second power. Similar to what we did with exponents, I want you guys to realize there's multiplication in between both of these. That's why it's going to both the radical as well as the 2. So this is going to give me 4 times, these cancel, 5, which is just 20, plus a squared is equal to, and now what we're going to do is 4 times 4 is 16. Radical 10 to the second power, the radical and second power cancel, and I'm just going to have times 10, and 10 times 16 is 160. So I'm going to have 20 plus a squared is equal to 160. And we're just going to minus 20 on both sides to get a squared equals 140. And just like previously, what we're going to do is take the square root of both sides, and 140 is not a perfect square. So what we're going to do is make a factor tree. Last time I chose numbers that I divided by 2 each time. I'm going to do something different. If I do like 20 and 7, 2 and 10, and 2 and 5. I just did this so you guys can see that it doesn't have to divide by 2. You can divide by anything. So what we're doing is looking for pairs. So we are only looking at our prime numbers, which is 7, 5, 2, and 2. I'm looking for a pair. As a quick reminder, you need 2 of a kind to take it out. So I'm only going to take out one of those. So radical 2, 2 times 2. I can take out a normal 2. And then I am left with 5 times 7. You look outside the radical, see if there's anything you can simplify, which you cannot. So I'm just left with 2. Then you look inside the radical and say, can I simplify anything there? And yes, you can. It is 35. It stays just like that because there's nothing in common. There's no pairs, so I can't take anything out. So therefore, your final value is, A is 2 radical 35, which we have written right here. If you have any questions, please, excuse me, I take that back. Go ahead and start video 2 now.